visit our weekly stats, we see that we've seen an increase in many of our numbers here, especially the number of DTAs executed, which we're now at 45. The number of both completion of DTA and IRB are up to 20. And we now have 8 deposited data sets, 4 for CoreNet, 3 for OMOP, and 1 for ACT. We always have new people attend this call, so I just want to remind everyone the overall structure of how we're organized. This is the Collaborative Analytics workstream call. Obviously, we're welcome to join any of the other calls and work streams. Our subgroups are listed here with their times, and these are all weekly meeting times. And everyone here is welcome to join any of these with those weekly discussions, as well as task teams that are now formed that are not shown here. These are more transient and lightweight in terms of not having the same kind of project management support, but equally enriching conversations happening there. We're going to hear from the cohort characterization task team today in some of their work. And there's task teams around different clinical domains. And I believe there's a task team that will be forming soon around ML and statistics. So lots of discussions that everyone can be involved in. Click at the link here at the top. Usman, if you could make sure that this deck is circulated, all of these links are active, so you can get all the information you need through this deck. So I want to really thank the Palantir team for making this training page, which is hosted within the N3C Enclave. And if you click the link, I'll just show it. I'll click it here. And a lot of great material here. What I really want to emphasize are all the webinars that are being hosted. So Intro to Foundry, all the dates are listed here, has calendars and how to join, as well as some of the advanced courses, such as the Advanced Contour, Pipeline Development, Slate Developer, Spark Optimizations, and I suspect other webinars will be added over time. The Palantir team may have more to say about this when they present, but everyone who has access to Knight platform should be able to find this and access it through this link, as I said. If you have any issues with access, I know we've had some people who've had questions about how to access, or they've been granted access but have had issues logging in. Please direct your questions to this email address here. Okay. Okay, so those are the brief updates. Now we're going to pass it over to Andrew and Amin, who are going to give us our weekly demonstration of the N3C Enclave platform. So, Andrew.
Great, thanks. So I will just share my screen here. And great. There we go. All right, can everyone see this?
Yes.
All right, so what we're gonna show today is a little bit different. It's our work on the COVID knowledge graph that we learned about a week or two ago. And we're gonna show you how it can be incorporated as part of the cohesive ontology that exists within Foundry. So this is just one example of and I'm trying to choose my terms here. I know there are ontologists on the call. It's one example of a controlled vocabulary or ontology that can be brought in, and we'll show you exactly how you can use it, but also how you could add others or replace it or customize it, however you'd like to use it. So I'm going to start here in the Object Explorer, where you work with the objects and relations that you've mapped. And I'm going to take a look at the subset, which are the drugs that are defined within the knowledge graph. They don't have a particularly large set of properties. They're quite minimal, pretty much just an ID and a name, but you could imagine joining in data from other sources to enrich these. And I'm just going to do a search for hydroxychloroquine. And there are actually two instances of this that aren't resolved inside the knowledge graph. I'm going to take a look at this top one. And here are the properties that we have. And I can actually go into a graph view of this object with its relations. And what we have here is the central object, hydroxychloroquine, linked to a set of relationships. And these are BioLink interacts with relationships. And they have a series of different properties, including a subject and an object and a source for where this information came from. And so I'm actually going to select all of these, and then I'm going to do a search for any genes that are linked to hydroxychloroquine and add those to my graph. So now I have brought back these 5 genes. And I'm going to continue the search going forward and just quickly demonstrate a slightly more sophisticated search, where I'm going to bring in all associations here, but I'm going to filter only to associations where the evidence is of a certain type. They offer a few different types here, and I'm going to require it to be variant annotation. And that's going to bring back a subset of the total relationships coming out of DHFR. And then finally, I'm going to see what, if any, drugs are linked to these relationships, to these associations. And I'll add those to my graph. And then just lay this whole thing out to make it easier. So you can imagine exploring all of the various relationships here between the drugs, the genes, the ontological classes and diseases, and all the other things defined inside the COVID-19 KG. And I want to also point out that the data is represented in the source that we downloaded it from on GitHub as a structured data set here with rows and columns, and we can actually tackle it in that form as well using the contour tool, which you've seen if you've taken the training here. And what I'm going to look at first is the 16 million edges or associations that are in this data set. You can take a quick look at what this, the structure of this data. And then what I'm going to do here is filter down to the various categories of both subjects and objects for the relationships. And I'm just going to remove the ones that are unclassified so that we can look at the types of relationships and how they're related, ignoring the ones that don't have a type. So now I want to do object category. And I'll remove the uncategorized here. And now I'm just going to quickly make a little heat grid to show the various types of associations and how frequently they kind of co-occur here. So we'll put the subject category on the x-axis and the object category on the y-axis and just count how many we have here. And basically, we have the most common relationship is between ontology class and publication here. We have 2.45 million of those. Well, let's take a quick look at the association of drug and gene here. So I've selected just that association, and now I can drill down and ask for additional details about the various genes and drugs that are associated according to this knowledge graph, and where that I can do further joins to understand their relationship here. So I'll pause there to ask for any questions, and then I'm going to hand it off to my colleague Mark to show how ontologies are mapped into the system and we create these object views. Okay, well, happy to hand it off then to Mark.
Yeah,
So
thanks, Andrew.
Justin asked, is this the most recent build of the knowledge graph? It is just a few versions behind, I think. We don't have the live connection set up. It's just one we downloaded. But we will set up a live connection such that it grabs every new version as they're released.
Now, how does new information get added to the graph?
Well, that I guess you'd have to ask the people that made it.
That would be Justin Reese, who just asked you the question.
Okay. And then there's a question about tracking new versions of data. So every time the pipeline runs, when we have a live connection, each transaction will be recorded as a creating a new version of the data. And you can always go back and look at past versions. Do the ontologies have SQL access to enhanced queries? So you can access these ontologies in their structured form using SQL, using vector or the code authoring environment. So absolutely to that question. And that, maybe that's it. Okay, Justin, or Mark, do you want, will you need to walk down the tree? So you can ask, you can write any, let me just go back and share because there seem to be a few questions about using SQL on this.
And if you're adding questions to the chat, please send it to all panelists and attendees. We're only getting these to the panelists. So I think everyone else is not able to see these.
There are also a couple on the Q&A as well.
Oh, okay.
So if, for example, I open this in a code workbook, so these are just the edges, and you would probably bring in the nodes as well to do something more complicated. But I can just grab a SQL statement here and write whatever I want and execute it against the ontology tables. And there were more in the Q&A, or it's weird, it's not showing me that.
Is Justin Reese able to, I don't know if he's a panelist and can comment on how this database is getting updated.
Yeah, in a very deliberate way, basically. I mean, if so, for example, we just merged a PR to ingest Kemble, so that will now appear if you guys pull the most recent build.
Great.
But basically, new stuff. Well, there's two ways new stuff can get in. One is if the upstream source updates some data, then we'll obviously pull that, and then we have several new ingests that we're working on, so those should be added. You know, on an ongoing basis in the next months, maybe a year.
Great.
If there's a high priority ingest that you guys would like to see, we could definitely prioritize that based on your needs.
Okay, well maybe now I can hand it to Mark to show how this data gets brought into the system.
Yeah, that sounds great. I will share my screen right here. And you all see, oh, sorry. Let me pull up a different window. Great. Can you all see the ontology editor with drug pulled up?
Yep.
Great. So I'm going to quickly walk through how we can get from that tabular data to this nice ontology of all these objects and the relations between them. So we started with those two data sets that Andrew mentioned, the edges and the nodes. And within Foundry, we can run some code that takes this big master node data set and looks at this category column and chops it up basically into a data set for each of those different categories, which are then going to become each of our different object types. And so Foundry has this nice ontology editor tool. And to create an object that's backed by each of those data sets, it's a pretty simple process. So you can see for our drug, it's backed by the drug data set from that folder that I just showed you. It's an easy process to just create one of these objects. And then what's neat is that each of the columns from the backing data set automatically get, we can easily just map them to the properties of our objects, just like that. And so this makes the whole ontology super flexible. If our big node data set suddenly had a category that we hadn't encountered before, it's very easy to create a new object type to represent that, and then just have these properties be updated based on the other columns of the data set. Additionally, like Andrew was saying, these data sets will periodically get updated every time more data is added in. And so new instances of these objects will automatically be created, and it's not really any maintenance that we need to do for that. So the ontology editor is also where we define the relations between object types. And as you saw on Andrew's graph, we use this association object sort of as the intermediary between two nodes to capture the data about the relationship between them. So for this drug object type, we have an association representing the incoming and the outgoing edges. And once again, this is all the updating is done automatically. You specify the source object type and the target object type, and it will perform a join on the foreign key. So within our edges data set, it will just look at the primary key listed for the subject and the object and automatically create all the links between the drug objects and the association objects. So a very flexible process. It allows the ontology to grow and expand as the data that we have access to is enlarged. And with that, I could answer questions or pass it off to Amin, who I think is going to show how this interacts with some of the other features in Foundry.
Cool, thanks, Mark. Do we have any questions right now?
This is Chenley. Hi, Mark and Andrew. This is great. This is very nicely showed how the analysis can be done on the knowledge graph within the Foundry. I think it relates to the work we are doing, like try to integrate the translated KG into the Foundry as well. So what our team and other translated team are working on is try to get the different KG together and in a distributed way, and then can be harmonized into like some kind of like the proxy layer called like a relay system. So I can see if we can somehow connect it to the knowledge graph ingestion. I think Mark just showed maybe via some REST API to bring you more knowledge graph data from the translator project, right? Will that work? We can explore some more detail, but that overall workflow seems should be working.
Yeah, that sounds great. We'd love to do that.
Yeah, because we are considering to set up some translator KG within the Enclave cloud, and to have those API, and then on top of that, there's like a middleware layer to harmonize the underlying knowledge graph. So, and then we can call the Palantir REST API to bring the data into the Palantir, or like, right? So then that will be the connection we can explore.
Yeah, there are a number of ways we could set something like that up. But we could set up something through an API. We could set up something through an ingest. We could do joins or API calls. It's really quite flexible.
Okay, sounds good. And then my follow-up question is, when you ingest the KG COVID-19 data, how that process, is that process need to be done with the custom code, or it's something with the existing, like a REST API of a Palantir platform?
So for this one, we did it as a one-time upload. So it was literally like you could just create a new data set and you could just upload any files you wanted. So if you have any CSV files, you could, any user on the Unite platform could upload and start building their own ontology. What we want to do is set this up as a recurring sync, which means that we would have sort of, we would have a process that is running on an NCAT server, and it would be periodically pulling in new versions of the data from when they're published by NKG.
Great, thanks, looks awesome.
Okay, and we have one question on the Q&A that says, how does ontologies, how do we choose which cross domains are getting updated and linked? For example, SNOMED has drug concepts and their parent-child relationships might differ from RX norm. So I think the story here is this is quite flexible. So the ontology editor that Mark showed lets you define which relations you want to create, and you can create multiple relations between different objects. And so then when you're exploring them in the graph view, you can say, let me go from this node to, for example, its parent. So let me follow one particular relation, or let me follow another. And it's really up to you to define how many different kinds of edges you want and which edges you want to follow. Okay. Let me, I think, move on for now to the next part of the demo in the interest of time, but happy to take more questions later, also over Slack. So the other thing that we wanted to show was, and this is a question that we got last week, was sort of what is a typical sort of first thing that a user might do after they arrive on the Unite platform, they want to start doing research. And so we've been building out a couple things that we're excited to show you. And I'm going to share my screen here. This is, can you see this form? Okay. So this is a form that we built that is sort of a project request form. And it lets you sort of say, okay, I'm a researcher. Maybe there isn't a project that I want to join right now, so I want to create a new research project to investigate something. So you would fill out this form and fill out a title for your investigation. So maybe investigating a curious phenotype. And
Amanda,
you would, yes.
I'm sorry to interrupt you. This is Ken Gersing. I think that, we have the data use request form, which we're going to be using. It's very similar to this. So I'm not sure. I don't want to confuse folks because there is going to be, and that gets funneled to the data access committee. So I'm wondering if I know you got some, I think you were going to have some dashboard things you're also going to show, or maybe we can go to that, or go ahead.
Yeah, Ken, I understand. I think we're basically going to, like the data use agreement stuff is separate from this. We're essentially going to need some way in Foundry for you to create, so in Unite for you to create a project that you can start putting your code in. And so this is really a form just to create that.
Yeah, no, I understand.
Yeah.
I think what
no,
we
totally.
were, yeah. So I just want to, I don't want to confuse folks because the data use request describes the projects which get sent to you. And therefore it helps you set up a workbench. So I just don't want to confuse folks.
Right. Yes, that's a really good point. This does not grant you access to any of the data. This just gives you a sort of home within Unite for you and your collaborators to work on the data after you've already sort of requested access for it and have all the necessary approvals. So this can be quite simple.
Oh.
Go ahead,
So,
Melissa.
sorry, this is Melissa. So I think what's going to end up happening, just to clarify, is that, you know, for right now, this is a great way for people to understand how to navigate the system. But in the future, I think what might work best is for those outputs of the data user request and data access committee review to directly feed into and automatically create the research projects,
That's
which
right.
will basically look and feel the same way. But for now, this is
Yeah.
perfect. But,
That sounds fine.
That's right. So I mean, I don't think they'll be using this because we need to connect the two, and then you'll get, and we're just working on them. Sorry, we have a meeting on this on Wednesday, so you didn't even know this. This is to try to tie the governance group with the projects. We'll be passing this information to you. So,
Okay.
but it'll be similar to this.
And I
In
think
that case,
they'll
let me
map
move quickly through
one-on-one,
this,
but
please.
there needs to be something within the platform that dictates which collaborators have access to the work. So whether we're creating it in here or whether it's being passed from an API doesn't really matter, I think, per what Melissa said, but there needs to be a concept of a project in here in order to guard the work, if that makes sense.
I understand. And that will be in there, and who will be on it.
Yes. Yeah, who are the collaborators, etc.
Correct.
Okay, fantastic. I'll just breeze through this piece to the, like we can eventually set this up so that it's automatically created through that form too. But for now, let me get to the part where sort of you've created the project somehow or another, and what do you actually end up with? So you know, some description or abstract. You select your collaborators. If they're selected through a different form, then we need to figure out some sort of mapping from those users to the actual users on the Unite platform. But right now, if you went to this link, you would be able to choose other users who have signed into Unite. So you choose your research collaborators, and this is one thing that we're excited about, is the ability to make the project searchable by adding tags from the ontology, and this is where it gets quite flexible. So this is something we could do after the fact. You could go to an existing project and you could just say, I'm going to add on tags. But in this project creation form that we were thinking about, you would kind of just say, you know, here are some drugs that we're investigating, or here are some phenotypes that are going to be relevant to this project. And when other people are searching for my project, I want them to be able to find it based on these tags. The tags that I was just searching through are actually being brought in directly from the KG ontology that Mark and Andrew were just demonstrating. So it's searching through drugs, genes, and human phenotypes. But this is really up to you about what kind of things you want to be able to tag research projects with in order to make them more discoverable. And so after a quick submission, you know, 30 seconds later, I have a home within the Unite platform to do research. And this is kind of the end result. This is what we're trying to get to. You can see here, this is itself an ontological object, and so it's linked to the researchers that I chose as the collaborators, and it also has a title that I can edit as one of the collaborators of this project. But I can also click into this folder where I can start creating anything really, code and analyses, and start doing research with my other collaborators. Okay, so this is sort of the home page for your project. That is the folder where you can start creating research. And if you were somebody else coming along and wanted to join a project, you would be able to find it in the same sort of graph explorer that Mark and Andrew were showing. And you could click into this tab and you could say, look, I want to be added to this project after the fact. And you would submit a request. One of the collaborators would approve it, and we could make sure that you got access to their folders. Again, assuming that you have signed whatever data use agreements or other checkboxes that need to be checked. Okay, that was kind of a lot, but I'll stop for questions.
I don't see the ability to have to update your keywords and tags. I assume that will be available?
Yeah, right now we were modeling it as at project creation time, but especially if we're going to be creating these projects in an automated way, it'll definitely be more important to add it as an after the fact thing. That's something we'll add. Thanks, Justin.
Okay, thanks. If I can take this screen back. I realized I glossed over the agenda, so we just heard the Palantir demo. We're going to move next to Tel and Heidi, who are part of the clinical scenarios group, and will give us an update on the characterization paper before moving on to Mark Suchard, who will present the Odyssey Hades tool set.
Yeah, thanks, Justin. Let me just share my screen here. All right, Justin, can you see the Google Doc?
Yes.
Excellent, thanks. This is the working cohort paper document that everybody can look at in the N3C Google Drive. We've been meeting twice a week and have had a really robust discussion each time. All are welcome, and the contact information is up there at the top. The next meeting is 6 a.m. Pacific tomorrow morning. BYO coffee. Key points just to kind of orient people to what we've at least draft decided on. You know, nothing is written in stone. We would like it to be really the largest, certainly US paper about COVID-19. And so we are shooting for a minimum of somewhere of 20 to 30 sites, but we're going to be watching the trajectory of sites adding data. And if we're still on a steep upward slope, then we will kind of wait for a hockey stick. And if that's 40 sites, that's wonderful. The goal is to submit soon thereafter with DAC approval, the Data Access Committee. We will need the DUA in place for this. The goal is for this paper to go to a broad clinical journal, and Chris and Melissa and others have started to send out some feelers to the editors of a couple of prominent ones to see who might be interested. The goal is for this to be a really descriptive manuscript, so not so it would be easy to give into the temptation to dive into testing associations, but we really want to do a rich description of the cohort here and set the stage for lots of subsequent work. The cohort for this paper in the first segment, or sort of prologue as Chris described it in the last call, will be the entire N3C cohort, and then includes the folks that we don't know for sure if they have SARS-CoV-2. And then the rest of the paper, in order to be in line with the other broad clinical papers, we will focus in on those who are PCR positive. We will stratify the PCR positive analyses by peak severity. A group of international trialists recently published in Lancet Infectious Diseases, the link is there, a minimal common outcome set. And this table from their paper shows their 10 category severity scale that we're going to use. Basically, these patients are not in the hospital. These patients are in the hospital with and without oxygen, and these patients are in the hospital with various forms of organ failure, and these are deaths. We will be using only the safe harbor data set. We don't need the LDS for the goals of this paper. And as I mentioned, we will need the DUA. So the temporary DUA, or the CDA as it's been described, doesn't cover this work. So these are draft form. Certainly if you have opinions, please add comments to this Google Doc. I think this has only gotten better as more people have weighed in. But table one was, I said, will be the entire N3C cohort stratified by the 4 phenotype groupings. This is the GitHub page for those phenotype groupings. So lab confirmed positive, lab confirmed negative, suspected positive, possible positive. And the rows of that table will be demographics, as well as sort of how many times they're getting PCR testing, and there are a couple of other rows that we'll wait to see if it comes out of the various CDMs. We realized that there'll be some systematic missingness according to the data model by which the data was submitted, and so we're planning on having a supplemental table to orient readers to that information. First figure is going to be a heat map of positive and negative case density. So again, using these 4 phenotype groupings across the US with the 20 or 30 or perhaps more sites. I don't think this will violate any site's confidentiality. The second table will be then focusing in on the PCR positive cohort and stratified by the severity scale that I showed you. And this will look, like a typical table 1 from a clinical paper. Figure 2 is going to be selected labs and vital signs that'll show severity of disease. These labs we've targeted first because they've been identified by that core outcome set as critical for studies, especially trials, to report. And then typical vital signs with an early in hospital course measure, and then perhaps a peak measure if we can find a way to make the figure not too crowded. And then we'll have a broader set of labs with, again, stratified by patient peak severity with some information about the distribution of each patient's physiology as represented by those labs. Current plan is to have a treatment pathways plot. I think we'll do probably 3 of these in panels. One, pathways of respiratory support, because I do think there's quite a bit of site variation here. Certainly lots of site variation in anti-infectives, both antibacterial, antiviral, et cetera. And then immunomodulation. We know that there's lots of variation here, whether it's steroids, anti-IL-1 activity, anti-IL-6 activity, other things. And then again, a supplemental table with a little broader treatment of meds and other treatments. We have a couple of figures we're still kind of figuring out how we want to make these look and where they will fit. We already have 5 tables and figures identified up here, so we'll see if these end up in the main body or in the supplement, but we'd like to show some sense of site heterogeneity across multiple dimensions, and folks have brought forward Carlos Saez's methods here. And then the Stony Brook team had done some nice work showing some lengths of stay in attractive ways that were stratified by invasive mechanical ventilation and age, a little bit focused in on whether or not sites are reporting orders so we can get to DNAR status in the first data pull. So we'll pause there and take any questions.
Thanks, Tal. I just put the link to that document in the chat window.
Right, and maybe I just want to add, Tal, this is really fantastic, and the group, I think the cohort groups made really tremendous progress over the last few weeks, and I'm really confident once we have the DUA and the data, we'll be able to go very quickly.
No, it's a great group, and I'm excited about getting this done, getting it out. Let's see. I can't answer Mike's question about which ACT site data is coming in or which PCORNet sites are coming in. Let's see. Tim Carey has a question. Is site a hospital or an integrated system? It could be either, depending on what that CTSA or N3C site represents. For example, in Colorado here, we have 2 N3C contributing. Both our health systems. One is, mostly a children's hospital, but we have a secondary hospital, and the other is a large adult health system.
All right. I want to make sure we have ample time for our speaker, Mark Sukerd, who will be talking about the Hades toolset. Thanks, Tal. Mark, if you could please present.
Yeah, I'm very welcome to be here. Andrew Williams invited me to come and speak a little bit about the tool stack that's available in Odyssey. I have to give you a small warning as I pull up my screen. And that is my 8-year-old decided I would only be important if I had 2 monitors. So he got me a second monitor, and this is the first time I've tried presentation mode with this. Oops, so are you seeing my presentation mode screen or the display screen?
The former.
Presentation mode, you need to swap displays.
Yes, all right, great learning experience.
There we go.
Perfect, great learning experience for all of us. So HADES, or the Health Analytics Data to Evidence Suite, is a large set of open source R packages that Odyssey has developed over the last 5 or so years that are really focused on providing large and small scale analytics, particularly for patient or population characterization, for example, the cohort type of study that we just heard about, but also large patient level prediction models and population level or causal estimation. And in putting a number of packages together under one umbrella, HADES, we've really strived to promote best practices for observational research. So we try to promote transparency in that the code and all of the artifacts that come into creating the code are completely open. Reproducibility, validation, there's a complete set of test units and continuous integration that go into all of the underlying analytics that we provide. And most importantly, reliability. A number of the packages are focused on asking what are the operating characteristics of the estimands that we're providing, and do they provide reliable evidence even in the face of the difficulties in observational research through confounding. Most of the Odyssey tool stack is based on R, and one of the reasons for that is we'd like to create tools that can easily be extended and hopefully incorporated into N3C that can run almost anywhere. They certainly run very easily on Windows, Linux, and Mac systems, and they execute against the OMOP Common CDM version 5, and one of the packages allows individuals to translate sort of an Odyssey-based SQL into dialect-specific SQL, so it can execute on Postgres, SQL Server, Oracle, Parallel Data Warehouse, Redshift, and even some of the big data platforms that are coming online. The sets of R packages that individuals are probably most interested in using are those that define specific designs of observational studies. So some of the designs that you might be interested in are new user cohort studies in a package called Cohort Method. We also have a package specifically focused on case-controlled type designs at large scale, and a number of self-controlled designs, which have been shown, at least in our own past benchmarks, to provide some of the most reliable estimates for observational studies. But I don't want you to get the idea that this is just for causal level estimation. There is also great work going into a patient level prediction package, which gives you a standard platform both to develop and train, but also to share models to ask about how their predictive performance works, not only in sample, but across sample and across different databases. Underneath these larger packages, which are the ones that you'll probably be using, there are a number of sub-packages that basically form the engines. The first are a collection of quality assurance type tools, which include methods for running empirical calibration. So if you have a number of negative control exposure outcome groups, you might use those as a set of negative experiments with which to calibrate your estimates so that they are returning the nominal statistics that you would expect. Basically, can we adjust out for the systematic bias that happened in observational studies? And then the latter two quality assurance packages are really built for doing head-to-head benchmark comparisons between different methods to ask how reliable the different methods are, depending on the research question that you might have. And then sitting on the bottom are a fair number of support packages that both allow for the interactivity between different databases using different SQL different SQL dialects for moving and manipulating large data objects from the SQL database to the local machine for access through these tools, and then also for doing the underlying large-scale regression. So I'm just going to give two very brief examples of execution of recent studies that are COVID aligned using packages from what used to be called the methods library, but is now called Hades. And the first is a mixture of a comparative new user comparative cohort design and self-controlled design. Is basically looking at the safety of hydroxychloroquine with or without azithromycin vis-a-vis an active comparator and its safety risk. And one of the reasons that Odyssey was interested in putting together and executing this study quite early was the initial excitement about hydroxychloroquine, and we wanted to ask what is the safety profile to help inform treatment choices. So as I mentioned before, this is a large-scale comparative cohort design that used both EHR and claims data retrospectively. So the largest contributors here in terms of data sources come from US claims data, but also European EHR and Asian EHR. We're also going to end up using in this the self-controlled design, so you can look at what is the relative risk of an adverse reaction like an arrhythmia on and off, for example, hydroxychloroquine. And one of the advantages of this study is because we have this underlying tool stack that's been robustly constructed, we could execute a large suite of negative controlled experiments to feel that we had confidence in their reliability. I'm not going to bring you to the actual code for the hydroxychloroquine study itself, since it's a little convoluted, but I did pull out a very quick example of using the cohort method package to execute almost end-to-end a new user comparative cohort design. And what I'm displaying here is the R code in just 13 commands that can bring you from the point when you've defined your target and your comparator and your outcome cohorts all the way through all of the analysis and the artifacts that you need in a simple cohort study. So again, there really are just 13 statements. These statements do implement a complete publishable study. We have published this study previously. The examples that I have written up here are for the relative safety of two different NSAIDs for a GI bleed, but you could replace that with new users of hydroxychloroquine versus new users of an active comparator for, say, the risk of some sort of arrhythmic event. The code here and the tool stack interacts directly with the database in the OMOP CDM. And one of the first steps in interacting with the database is an automatic procedure that generates a large number of baseline characteristics about these individuals. In this case, one command will generate all the features we know about the possibly million individuals based on their demographics, every drug at various levels of definition hierarchies, every condition at different levels of hierarchies, procedures and observations that these individuals had in this new user design at their point of initiation into their cohort and back. In these 13 commands, we use all of those baseline features to develop a propensity score model. So we use the information to predict what's the probability that they got one treatment or the other, and then balance or stratify on that propensity score model to try to adjust for the observational bias that we have non-random treatment assignment in this case. In this particular case, it's based on one-to-one matching. You can use propensity score matching. The commands themselves are straightforward for adjusting how you'd like to do the adjustment. And in the end, we fit a time to event model. And in this case, it uses all of the same covariates that went into the propensity score model itself. So you could do a robust regression quite quickly. When we execute these 3 commands, we also get out all of the study artifacts that you would need for your publication. For example, there's a simple command here that generates your preference score distributions. So these are the probability of treatment given you're in one of the 2 target or comparator cohorts, from which you can make assessment of, are these cohorts in clinical equipoise? Are there enough individuals who could have been randomized to one of the 2 treatments? Or are these 2 populations so different that we shouldn't be trying to draw a causal estimate from a difference between these? You can look at the propensity score distributions after matching, and in this case, after matching, the populations look very comparable. You might look at covariate balance. So of the 10,000 or so different features that we pulled out from these individuals, how balanced are the cohorts before and after matching? So you don't just get the balance on the 20 or so demographics that you might think of a priori to check, but you get balanced diagnostics on all of the features that we have on the individuals. And in this case, they're all less than sort of a nominal cutoff of 0.1. So depending on which rule of thumb you'd like to go with, this demonstrates extraordinarily good balance between these cohorts. You can look at features which were imbalanced before and are now balanced after to make sure that you've captured sort of known confounders. And of course, there's a Kaplan-Meier curve output. You get your, kind of your attrition diagram. And of course, in the end, since this was a Cox proportional hazards model, you'd like to know what is the relative risk for the different treatment effect. And in here, for this simple example that I went through, there is not, evidence to reject the null that there's a difference in the risk for GI bleed. But I brought up this example to show you that based on this tool stack, it is quite straightforward in your own workbooks to piece together the exact study that you would like by mixing and matching the different features that are appropriate for your particular exposures. Likewise, the hydroxychloroquine paper used a self-controlled case series design. There's a self-controlled case series package. Each of the packages are fairly well documented, including complete vignettes and simple examples that lead you through the major steps that you need to execute a study under the different designs. I'm going to finish with an application of this tool stack, which is a bit more real time, to show how we used it as the COVID pandemic has been unfolding. And one of the initial questions that was of concern to individuals that I work with in cardiology was the different relative risk of susceptibility for people who are taking RAS inhibitors or renin-angiotensin system blockers, since these interact with molecules on the surface of lung cells that SARS itself interacts with for its cellular entry. And there was some question about the relative risk for individuals really taking ACE inhibitors or the most popular antihypertensive medications. So using this tool stack in Odyssey, we had a work group that developed a comparative cohort design using prevalent users of RAS inhibitor, so an ACE inhibitor, versus an active comparator, recruited new data sources. In this case, these were large EHRs, including US Department of Veterans Affairs, and CityApp, which is the database that covers the primary care, so universal primary care in Catalonia. So both the VA and CityApp cover populations of about 10 million individuals. And I'm not going to go through the actual steps involved in executing this study, but I'm going to use this example to show what some of the open artifacts that are generated. The tool stack generates all the artifacts that you need for your paper, but also that you can provide to other researchers so they can explore your study to ask, is it necessarily reliable? Did you adjust for the appropriate confounders? Is there some residual bias that we need to put in there? So the Hades tool stack itself generates data artifacts that go into a Shiny app. And there's a website here which you can pull up right now to go through all of the artifacts from this study. I'm not going to do this in real time. I'm just giving you a screenshot of some of these artifacts. So for the entire study, you can pick the 2 target and comparators that you'd like to look at. In this study, not only did we do ACE inhibitors versus calcium channel blockers, but we did ACE inhibitors including ARBs, not including ARBs, monotherapy, combination therapy. So there are lots of different comparisons. For the specific outcome that you might be interested, our primary outcome here was COVID diagnosis, but there was also hospitalization under a number of different designs. And then you can click through each of these different tabs that tell you about the power of the study. So the number of comparator subjects that you're looking at, what your attribution, what your attrition looks like, what were the characteristics from which people fell out of the study and you were losing generalizability. You can pull up all of the population characteristics. So in real time, you can generate that table 1, but not just against the 20 or so things that you find are most important for your paper, but against all of the tens of thousands of different features that have been generated. You could do diagnostics on the propensity score model and ask, is it adjusting for known confounders? And after we apply it, do we find covariate balance across these individuals? All the way through to looking at different effect estimates. So down here on this slide, I just have the power tab pulled up. And in this particular study, we're looking at, roughly 40,000 new users of RAS inhibitors versus 14,000, prevalent users of calcium channel blockers and thiazides, and the number of events that happened in each of the groups, and what their at-risk distribution was for this particular study. I mentioned covariate balance. It's very nice to look at. Here we have it in an interactive form where you can pull up and hover over each of those covariates and ask what they are. In this case, there are definite prescribing differences for ACEs than for non-ACEs, particularly in the VA. That comes to a counterindication of ACE inhibitors for African Americans. And as you might expect, before balancing, there were large racial differences in our cohorts. And after balancing, we were able to adjust for those differences. Finally, I want to say that since this tool stack has been developed and been around for a couple of years, we've had the opportunity. Sorry, is there a question? No, I'll have a chance for that. There's been an opportunity to perform a large amount of benchmarking. So we've been able to put together large-scale studies which compare the relative performance of different design choices. And we're interested in doing a design choice benchmark in emerging studies that one might be interested in doing, particularly in COVID, because as data are growing, it's almost as if we're looking at these problems prospectively, as opposed to the retrospective approach that most observational research has taken in the past. Finally, I don't want you to think that I did a large amount of this work. Unfortunately, I've done very little, and no work is ever done in a vacuum. So there are a large number of other contributors, but the most important in terms of these packages include Chris Knoll, Jenna Reps, Peter Reinbeck, and Martijn Schumi. So let me pause here and finish up with a couple of questions that you might have.
Thanks, Mark. We can keep this Zoom meeting running for a few more minutes for questions. I'll start with just one question. This might be for Andrew in terms of to what extent that these packages have already been integrated into the Enclave, and do we expect there would be issues in being able to utilize them natively in the platform?
Not if we're able to put the whole Odyssey tool stack in its native form up in some way. So that is my fervent wish and goal. I think we have yet to have the very first meeting about implementation yet. So we've had the sort of options for how implementation might go before us for a while. But I think what Mark just displayed and the obvious value of it is one of the reasons I'm really keen on making sure that its native form is really preserved. There's an enormous amount of value for doing things as they were built, which was with very clear purpose in mind, and as excellent as all of the Palantir work is, and the efforts to kind of reproduce some of these packages inside Palantir, I think it's going to be infeasible to do all of the work that and replicate all of it in that fashion. So I'm really eager to make sure that happens, and hopefully in the next 2 weeks or so we'll have a positive report on that being done.
Yeah, I mean, it's a wonderful opportunity for those of us involved in methods development to engage not only N3C, but also Palantir. You know, if one has a complete Odyssey tool stack all the way down to all data within, you know, OMOP CDM, then all of these tools work at, are rather robust and have quite a bit of use. But there are a number of packages here at kind of the higher level. So the design choices that for individual studies that aren't quite as dependent on the underlying representation of the data. And so there are also opportunities for Palantir to interface directly with the analysis packages as opposed to the data manipulation packages, so that we can, support as broad a platform, or, as broad a number of resources as possible.
Any other questions?
Mark, that was very impressive. Do you have any impression of what the learning curve is like for new people coming to tools like this?
Some might say easy, some might say steep, but let me give some good examples. So as the epidemic first started to take hold around the world, and Odyssey started to engage directly in wanting to run comparative effectiveness studies, it was kind of at that point that we as a community engaged with the VA and engaged with CityApp. And it was within the order of weeks that, data were of, the ETLs were of sufficient reliability, the tool stack was up and running within CityApp and within the VA. And within a month, kind of the first sets of results were coming back. Now, that's kind of an ideal setting, right? One has a whole community helping, helping a specific data asset to move things forward. But it does show that it certainly is possible to onboard new data resources and individuals in the time scale that we need to be doing it. Now, a small caveat: there was a fair bit of hardware learning curve in, for example, in both the VA and the CityApp. And so the first time executing a study using this tool stack was certainly 5 to 10 times more difficult than the second. But I think we're starting to see the value, right? 90% of the effort went into hydroxychloroquine, but then when it came, all right, we're going to do ACE inhibitors. Maybe next we'll look at alpha-1 blockers. It starts to become easier and easier.
And there's a really excellent, book, the Book of Odyssey, and a whole bunch of tutorials for the different elements involved. All of those are linked on the dashboard that N3C is supporting. There's really great tutorials also on the vocabularies and so forth. So that's all available. And I think some of the learning curve that happens in a federated system setting will be a little bit accelerated when you've got a single place where all the data are living. And once the kinks are worked out after the first couple of runs in N3C, it won't be completely smooth sailing every single time, but I think it's not like coming to a fresh site and bringing it in and getting all of the different hardware and other aspects figured out, those will be more or less one and done.
Yeah, there's a good technical question from Ken Wilkins, who's asking about the cohort method, and kind of the generic examples that we tend to show with the cohort method do not accommodate time-dependent confounding. And as we can realize, as practice is changing and our knowledge of COVID is growing over time, we're certainly going to be confronted with huge sources of time-dependent confounding. So I'd like to say that the cohort method that we've constructed certainly does entertain adjustment for different types of time-dependent confounding and time-dependent outcomes. Most of the examples that we've illustrated, there's kind of reference to the last symposium, for example, the last Odyssey symposium, hasn't gone down that route. But since the code is, it's general R code that most statisticians feel relatively comfortable working in. There's no real hidden layer, hiding away the machinery. One can certainly, tweak is not quite the right word, but one can certainly adapt these to, emerging approaches for observational research, which include any type of time-dependent confounding that you might be interested in. It's a question that I'm personally interested in. So Ken, if you want to reach out to me, we can have a further discussion about it.
Yeah, this is Mike. Sorry, Mike Bisich, University of Pittsburgh. Sorry to interrupt. I was curious. I had asked in the chat box about the ACT site that had ingested data, and Melissa said she could answer it live. I was wondering which site that is. Melissa?
I think Melissa may have left. She left something in the chat suggesting that she thanked everyone, so that may have indicated that she had to leave.
All right, she was gonna. It said that she had was able to answer it live, but didn't get to it, I guess. Does anybody else know which is the ACT site or the Picornite sites that have been ingested? All right, with that, I guess good work. Thank you. I hope to get those answers.
There is a response from Julie McMurray.
Hi there, Mike. It was Melissa asking me to look up the information, and it was Kentucky.
Much less is on the mic.
Thanks a lot for the ACT site. It'd be nice to get the Picornite site too. Thank you very much.
I'm not sure if Ken or Chris. I see Chris on the call as well, so maybe Chris might have the information handy.
I think we may have gotten the answer, it being Kentucky, unless you were asking for the Cornet. But are there other questions to Mark about the?
There was in cohort method. Do we have the competing risks set up? And the answer is I do, but it's not been standardized yet. And we can actually execute competing risk model on the order of millions of individuals, which isn't so relevant for COVID, but has been a real problem for competing risks in the past. So people who are interested in different extensions to these packages, it's an open community. We have the methods development has regular bi-weekly meetings. I know exactly what you want, right? Another meeting. But meetings are small and work is large. So please engage yourselves.
Yeah, in addition to just the practical value of being able to implement these studies in a small number of commands, as Mark illustrated, I think the method evaluation framework and the overall approach to understanding the performance of different methods is going to be of value to the N3C community. And there's open questions now about how we're going to be validating packages that are endorsed as sort of officially kind of supported in some sense by N3C. And I think this is a very thoughtful approach to doing that in an empirical way that, again, is embracing open science practices of making it all inspectable and reproducible and so forth. So I think apart from just being able to do the studies, the way of evaluating methods is also really worth noting here. well, since Melissa and Justin have left, I don't know if we call a meeting on our own or.
I think we did a great job. I think we should wrap it up. And this was great. A lot of really fantastic stuff this time. This was a great meeting.
That was a great meeting.
Great. Thanks, everyone.
Okay, thanks.